All right, so let's go ahead and work this projectile problem. And in this problem, we have a baseball or some sort of object that's thrown or fired or whatever at a speed of 30 meters per second at an angle that's 35 degrees with the horizontal. Okay? And now, the first step in any projectile problem, before we even get to part A of this problem, is we're going to want to know what the individual x and y components are. Okay? So we're going to want to know what is the x component here of that vector. And then we're going to want to know, well, what is the y component? So here's our y component. Okay? The reason we want to know this is because, remember, for two-dimensional motion like this, we can completely separate the vertical and the horizontal motion. Those two things can be completely separated. So let's go ahead and calculate the x and y components. So the x component of this vector, so it's v initial x. Let's just stick with vx initial. That's probably the best way to do it. Vx initial. That's 30. So remember, we use the cosine here. So that's 30 times the cosine of 35. And when you do that calculation, you get 24.57 meters per second. My dog is licking my leg. And to find the y component, we need to take the sine. So Vy initial is 30 times the sine of that 35 degree angle. Okay? So when you do that calculation, you get 17.21 meters per second. Okay? So those are two things that we're going to need for this problem. Okay? Now, part A asks us to find the maximum height. Okay, it's asking us to find the maximum height of this projectile above the ground. So basically, this would be exactly like being asked the question, you throw something upward at 17.21, our y velocity, throw something straight upward with the velocity of 17.21 meters per second, how high does it go? Okay? It's the exact same problem because we can completely separate x and y motion here. Okay? So if we want to know how high does this go, well, what do we know about the y velocity at the top of the flight? Okay? Well, so at the top of the flight, the y velocity is 0. So our final velocity then is going to be 0. Okay? So we know what our initial y velocity is. That's our final y velocity. We need to figure out how high does this projectile go. And so with the information that we have, that we're given, the best equation to use after we know what our acceleration is, it's negative g. We have our two y velocities. The best equation to use will be this one. Vy final squared equals Vy initial squared. It's usually plus 2 acceleration times delta y, but since we know that the acceleration is negative g, it's actually minus 2g delta y. Okay? And delta y then is going to be our maximum height. Okay, so let's plug these numbers in here. Vy final is 0. Vy initial is 17.21, and we have to square that. Minus 2g, g is 9.8. And then times delta y, and that's just our height. That's our maximum height, h. We'll just call it h. Okay, so we do some arithmetic here. We square this. bring it to the other side of the equation by subtracting it, and then divide both sides by -2 and -2 and 9.8. And when you do that, you get a maximum height that is 15.1 meters. Okay? So that's our answer to part A.